Now here today we're going to see how do we simplify radical expressions, which are expressions inside the square root. The best way to do that is to actually do some examples. So let's start. Now there's a rule in mathematics that says if you're multiplying inside the square root, which in this case we have 100 times b to the second, you can separate each of those multiples. So the square root of 100 b to the second, that is equal to the square root of 100 times the square root of b to the second. If they're multiplying, you can separate them. And now we treat them individually. The square root of 100, that's 10. Now, how do we simplify the second exponent? Now, you got to remember that if you're talking about square roots, and there's no number here, there's always an imaginary 2 there. Now, the moment that your root matches your exponent, they cancel out. Again, if your exponent matches your root, they cancel out. So now you just have the inside, which is 10 times this whole thing cancels out. So it's 10 times b, which is just 10b. That's a simple example. It gets a little more complicated, but it follows those rules. Now, let's look at the second example here. Now we have, again, the square root. They're multiplying, so you can separate them. Square root of 125 times the square root of n. Now again, we're going to try and simplify that 125, but I know that 125, I can rewrite that 125 as 25 times 5. So the square root of 25 times 5 times square root. Now, why did I wrote 25? Because when you know the square root of the number, you can take it out. So I know that the square root of 25 is 5. Well, I mean, if you want to look at it this way, we can rewrite this still as square root of 5 squared times 5 times the square root of n. Again, when there's always imaginary 2 there. So when your root matches your exponent, they cancel out. So this 2 cancels out. So now we can bring this 5 outside. So now we have 5 square root of 5 times square root of n, which essentially is 5 multiplying two square roots. You multiply the inside, so we have 5. And that's our final answer. Okay, so now let's look at another example here. We have 216 times k to the 4th. Again, if they're multiplying, you can separate them. So now we essentially have the square root of 216 times the square root of k to the 4th. Okay, so let's concentrate with the first square root. I know that 216 I can rewrite as 36 times 6. Now, why am I choosing 36? Because I know that my root is 2. So I want to see if I can rewrite that 216 as the second exponent. But I know that 36 is 6 to the second. So I can rewrite 216 as 6 to the second times 6. So let's rewrite that. 6 to the second times 6 times. Now, let's look at the second exponent again. There's an imaginary 2 there. That's your exponent. I mean, that's your coefficient, your root. Is there a way for me to rewrite that k to the 4th as exponents of 2? Well, let's see. K to the 4th. That is equal to k to the second times k to the second. Because you gotta remember that when you multiply, you add exponents. So I can rewrite this k to the 4th as k to the second times k to the second. Again, I'm trying to rewrite everything that I can in terms of exponent 2 because I want them to cancel out. So now you see that this 2 is going to cancel out with this 2. So now on the first square root, we can take this 6 out because the exponent cancels out. So now I have 6. I'm sorry. Does not look okay. So again, the 6 goes out, so we have 6 square root of 6 times, what do you notice about here? This exponent cancels out because that's 2. This exponent cancels out because it matches your root. So we have essentially times k times k. And now we multiply the outside. So we have 6k to the second square root of 6. Because essentially what you're doing, you're having a big multiplication here. You have 6 times square root of 6 times k, but this k times k, it's equals to k to the second. So essentially you have 6 times square root of 6 times k to the second, which is just 6k squared square root of 6. Let's look at some more complicated examples here. Again, if you're multiplying inside the square root, you can separate each of those square roots individually. So we can rewrite the original, and again, we're simplifying here again. We can rewrite the original as square root of 75 times square root of x to the second times square root of y. Okay, so now this is what we have. How can we work this out? Is there a way for me to rewrite 75? Is there a way for me to rewrite that 75 as something raised to the second? Well, let's see. 25 times 5. I'm sorry. Yeah, 5. What? Times 3. I'm sorry. So 25 times 3, that is 75. So 75 I can rewrite as 25 times 3, but 25 is 5 to the second. So 75 I can rewrite as 5 to the second times 3. So we have 75 I can rewrite as 5 to the second times 3 times, we don't really have to worry about the second square root because it's already written as an exponent of 2. Again, imaginary 2 there, that's our objective. I want to rewrite everything as exponent of 2 so they will cancel out. So I'm just going to rewrite it here. I mean, the y is y, so there's really nothing you can do about it there. But now, let's make some space here. So now let's see. This 5 to the second, I can bring it out. So now the first square root, it becomes 5 square root of 3. Now let's look at the second square root. The exponent matches the root, so it cancels out. So I just have an x, so times x. And there's really nothing you can do about it here. So times y. Now we multiply outsides with outsides, inside with insides. So 5 times square root of 3 times x times x. Multiply the outsides, so it becomes 5x. And then you multiply the square roots, which essentially becomes 3 times y, which is 3y. And that's our final answer here. Let's look at one more example here. Okay. So again, if you're multiplying, you can separate the square roots. So that's the first thing I want to do. Square root of 36 times the square root of x to the second times y to the third. Just separate them. Now, it's pretty straightforward. Square root of 36, that's just 6. So that's easy. Oops. It's just 6 times, again, the square is 2. When your exponent matches your root, they cancel out. So what do we have out? It's just an x times y to the third. Now I know that y to the third. Is there a way for me to rewrite this as exponent of 2? Again, exponent of 2 because that's the root. Yeah, y to the third you can rewrite as y to the second times y. So I can rewrite the third expression as y to the second times y. So we have 6x, but again, when your root matches your exponent, so this 2 cancels out, and now this y comes as an outside, so we have cx, y is square root of y. The 6x was already outside, so if we bring this y to the outside, it becomes 6xy, and now what remains is the y on the inside. Now let's look at our last example, which looks a little more complicated. Okay, so again, it doesn't matter if you're multiplying 20 things inside, you still do the same. You rewrite it, each of them individually. So we have 3 times square root of 24 times a to the fourth times b to the second times c to the third. Okay. Now let's look at each of those square roots individually. So we have negative square root of 3. 24. Is there a way for me to rewrite 24 as a multiple of the square? Let's see, how about 4? 4, I know the 4 is the square root. So 4 times 4 gives me 24. So that's 6. So 4 times 6. I know that 4 is 2 to the second. So I can rewrite this 24 as 2 to the second times 6. So 2 to the second times 6 times a to the fourth. Is there a way for me to rewrite a to the fourth as an exponent of 2? Well, a to the fourth is a to the second times a to the second. So let's rewrite that. A to the second times a to the second times b to the second is already written as exponent of 2, so nothing you can do about it. And c to the third I can rewrite as c to the second times c. Okay, let's erase this so you will not get confused. It's not part of the work, this is just some extra stuff on the side. Alright, so now, can we simplify the following? Yes, we can. So we got negative 3 stays outside. Now here, see that this 2 is exponent of 2, which matches the root outside. So this 2 goes outside. So now we have negative 3 times 2 square root of 6 times cancels. So because there was a 2 outside, so now it becomes a times a becomes outside, which essentially is just a squared. So let's just rewrite that as a squared times a squared times, there's a 2 outside, it cancels, so times b, this 2 cancels out, so times c, and now we still have one c inside, so square root of c. So now we multiply everything. We have negative 6 a to the second b c times 6 square root of 6. Again, how do we obtain our final answer? Because you multiply the outsides, so you multiply all the outsides. Let's rewrite that in different colors. Maybe that will help. So the outsides, you multiply them. So now it becomes negative 6 a to the square b c, and the square roots, you multiply them. So now it's 6, and this is our final answer.